Hi everyone, I'm Roger. I'm a software engineer at Roblox. I'm also a committer on the vLLM project. So I've been working on vLLM for the past, I guess 5, 6 months. So today I'll be talking about the multimodal models in vLLM. And as a sort of intro and kickoff, this talk will be about like how like the history of supporting transformer-based multimodal models with vLLM. We'll show like a brief example of how to use a vision language model, which is one kind of multimodal model in vLLM. And we'll also talk about some upcoming changes and the future roadmap items. But this talk is not about diffusion models. We won't be talking about stable diffusion. That's not something we plan to support in vLLM yet. And we also won't be talking about multimodal output, which means image, video, audio generation. That's also something that's not on the roadmap currently. So we'll be focusing on multimodal inputs, but text output. About myself, I'm a software engineer on the ML platform team at Roblox. We are the platform and the infrastructure to support any kind of ML workloads, serving, training, batch jobs at Roblox. And we are indeed hiring, and here's a link to the direct job posting from my team. So feel free to check it out. For myself, I've been working on vLLM since February this year. I came as a user of vLLM as well. So my first work was around, the serving benchmark framework on the repository to compare different serving backend out there, TGI, TNCRT, LLM, and vLLM. We actually hosted the third vLLM meetup, third, fourth. Yeah, we're talking about the serving benchmark results as well. And for the past 3-4 months, I've been working on supporting multimodality on vLLM. And it is actually a team effort. So here I would shout out to Cyrus from Hong Kong. He's a postgraduate from Hong Kong, and Xiaowei from Anyscale, who are the two main collaborators with me to working on supporting multimodality. And there are also some community members on the shout out they have contributed to the vision language model support very recently. And last but not least, my colleagues at Roblox for supporting me working on vLLM. We also have a lot of like offline discussions on the design decisions I made to the vLLM architecture. So first of all, for those of you who are not really familiar with like large multimodal models, here's like a very brief intro of how they look like. So very recently, there are a lot of development into extending language model into different modalities. That means, video, image, audio, but they mostly leverage the same kind of technique where you have an encoder that's for the modality different from text. So this can be a vision encoder, as you can see from the left-hand side here. It could be audio encoder, as you can see from right-hand side here. These encoders encode your, multimodal inputs, they encode image, they encode audio into embeddings, and you concatenate these embeddings with your text embeddings to form your final embedding, and you pass this final embedding to the language model for the next token generation, text generation. And this is why it makes sense to support such models in vLLM, because vLLM itself is a very space efficient serving engine for decoder-only language model. And all we really need is to add that additional multimodal encoder into the infrastructure to support that kind of inference pipeline. And that is why we are working on this. So on the left, Llama architecture, vision encoder, that's a clip. On the right, you have Q and audio, they leverage an audio encoder together, both models together leverage the language model as is. And I'll briefly talk about like a overall history of how we support multimodal models in vLLM. So back in March 2024, Xiaowei from Anyscale made her first PR for POC support for Llama 1.5. This was a popular vision language model back then, but this PR I have linked here was really a POC, and I'll talk about that in a bit. Why it's a kind of POC, not really like production ready PR. And then in April 24, I think Xiaowei decided to take a leave from vLLM for a month or two. So I kind of took over this workstream. I made the first RFC for refactoring the multimodality support, and this RFC has since become like a tracker for us to keep track of any update and roadmaps items we want to put out there. So I encourage you to take a look at the RFC later. The first milestone we achieved was in June 2024, when we refactored the first portion of modality to support end-to-end inference that's compatible with OpenAI Vision API. That means you can use the vLLM OpenAI server to serve a open source model, but you can call it the same way that you call open like GPT-4v or GPT-4o. The second milestone we did was to generalize the initial work that's tied to vision language model to all modalities, meaning you can plug in like an audio language model if you want, or like I don't know what's out there, the video language model into vLLM. And we also support dynamic input shape of the multimodal inputs that I will talk about in a bit as well. And today we have 9 vLLMs added to vLLM. I have a few examples here. We haven't got any kind of a different kind of modality model, like audio language model, added to the vLLM architecture, or I guess vLLM support yet. But these should be very easy to be added or to be supported by vLLM. And finally, I do have my Q3 roadmap link here, so feel free to check out. So as I mentioned, the first PR from Xiaowei back in March 2024 was really like a POC kind of support for vision language model in particular. And here's a screenshot of how that looks like back then. To call out here, it only supports offline inference. As you can see, you can only interact the model with the OpenAI, with the LLM class inside of the OpenAI API server. And a few things to know here is that it actually only takes the pixel values of the image inside of a pillow image. A good analogy here of pixel values to image is like your prompt token IDs to prompt. So you have to pre-process your pillow image to generate these pixel values and then feed them to the LLM class. The other thing to call out here is that you have to like format your prompt to insert these placeholders for the image embeddings, and you have to know beforehand how much space or how many, like the size of these embeddings beforehand. And these are actually not that easily inferable from the model repo, or as a user you don't know what they are unless you really know how the model works. So as you can see here, not very user friendly. A lot of metadata you have to know beforehand to initialize the model and to call the model. But today, to initialize a vision language model, all you need is like, just like every other LLM there, just give me your Hugging Face model ID. And to run the actual, offline inference, you can just pass the same prompt format as you can see from the Hugging Face model repo, and your multimodal input, that the image input is no longer need to be the pixel values, but you can just open with the pillow image library, which is a very standardized library in Python to process image input and pass that to the LLM class. So in order to support this, as you can see here, we have to bring in the image processor to convert the pillow image to the pixel values. That also unlocks us to do like end-to-end inference with the API server. You can serve the model with the OpenAI API server, and you can call the model with the same API that OpenAI supports. Here on the client section, this example here is what I copy from OpenAI Vision API documentation, except I changed the model here to be the open source model that you serve with the API server. So both image URL and base64 encoded image input is supported with the OpenAI server. So that sort of wrap up the first milestone that we did for multimodal models. But the second milestone was to support dynamic size of multimodal embeddings. Recall here that for Llama 1.5, the size of the image embeddings is always 576. It's a fixed number for this model. But recently, there has been a lot of changes, I guess development for multimodal models, where the size of embeddings can change depending on the inputs. So here I have a screenshot from the Llama 1.6 paper or Llama Next paper, where they dynamically decide the size of the embeddings on the fly depending on the resolution of the original image to determine the best, I guess, like the best size of the embeddings to be fed to the LLM. So this sounds trivial. Your underlying task is that now your multimodal input or each image has a variable length of embeddings. So you just need to know how much space to expand in your panel embedding input to the language model with the correct number of vision embeddings or visual embeddings. This in Hugging Face transformers is done in the forward pass. That means your original sequence length is, let's say, 10 tokens, is getting extended to 600 tokens or 600 size. And these tokens get transformed to embeddings, and that get fed to the actual model to do the generation. But the problem of this kind of workflow or inference pipeline or pattern is that it doesn't work quite well with vLLM, because if you know the internals of vLLM, or if you have read some code from our code base, you will see that we need to know how long the final sequence looks like, or how long the final sequence is at the scheduling time. So if you put that into actual forward pass of the model, you will sometimes run into UMI issue, because you are actually taking more space than you are supposed to do during the actual execution. And also, we could have just like hack it by adding some script or adding some util function somewhere in the code base to pre-format your prompt or sequence with the additional placeholders. But what if we have inputs from multiple modalities, right? Like what if right now we could design a solution that only works for Llama Next or vision language model in general. But what if like in the future there are models that can support multiple modalities? Like what if I will talk about this in later on, but Llama 3.1, as some of you might have read from the paper, already supports both image, video, and audio inputs. Like how do we design a good architecture that can support multiple modalities at the same time? So we did a lot of like design decisions and refactoring, but we ended up with is like a registry-based solution. So basically for each model that supports multiple modalities, we have two registries. One is the multimodal registry, where you register the model with the accepted modalities. So I can tell Llama Next for potential generation to be able to support image input, because that's how the model works. And in addition, you can add the logic to pre-process the image inputs, because sometimes these multimodal processor is not available on Hugging Face. The model owner could have just like defined the logic within their own model repo, and so you cannot really leverage the kind of auto processor from Hugging Face to do that. And also, they can we need this registry to define like the max length of the embeddings that each sequence takes, because we need that number to profile the engine to know how much space we have for the KV cache afterwards. The second registry we have here is called like input registry or input processing registry. Basically, what it does is that if you recall, I talked about how we have to extend, let's say, a prompt of 10 tokens to a prompt of 600 tokens, because we need to have the additional placeholder tokens for the multimodal embeddings. So this registry is to incorporate that logic. Maybe sometimes the model will have additional patches or additional tokens logic into the final sequence. So we want to have a standardized way to register this logic there. In Hugging Face transformers, this logic is sometimes defined in the forward pass, as you can see from the left-hand side. Sometimes it's defined in the tokenizer, and sometimes it's defined in the processor, and it's like stack scattered here and there. We want to have a central place where the developers can, register this logic very easily with our code base. So that's how it looks like to support a kind of multimodal model today on vLLM. And since the refactoring kind of work, we actually drew a lot of attention from the community members on supporting multimodal models. As you can see here on the left-hand side, we have, I think, nine models supported today. And 4 of them actually come from, community members like Fuyu, Inten VL2, 5 Vision, 5.3 Vision, and MiniCPM-V. most of them are not like they are not even available on Transformers code base if you look them up. In fact, like the model owners themselves define their own like model code within their model repo. So if you want to leverage Transformers to support them today, it wouldn't really work that well. But because of the refactoring work we did, it's easier for the developer himself to pour that code into the vLLM code base to have them support it. And then on the right-hand side, I have some like future roadmap items that we are looking at in Q3 and maybe Q4. I want to call out the multi-image video input as like a top priority item we have here. Previously, a lot of models, in the open source world, don't really support like multi-image input that well. That's why for now, on vLLM, all the multimodal models that we support today only support single image input. But we did observe that in the past 2 or 3 months, especially with Llama video came out, there are a lot more development in that world. And video, in essence, is really just like frames of video, so multi-image. And there are also a few more items that they were looking to work on. Whisper is also one of them to support encoder decoder multimodal to text models. And for the detail, you can check out the link here for the roadmap. And I welcome, we welcome any contributions and feedbacks to this workstream. So feel free to leave a message or leave a comment in the issue and tag me or other committers from vLLM. And last but not least, I want to briefly talk about the multimodal Llama 3.1. So I don't know how many of you have read the paper or tech report from Meta on Llama 3.1, but they did talk about the multimodal version of Llama 3.1. So here is the overall architecture of the model. And as you can see here, on the left, we have a image encoder. On the middle, we have a video encoder, kind of aggregator kind of thing. And on the right, we have a speech encoder. One thing I want to call out here is to have, I have been already thinking about how to have this model supporting on vLLM, but one of the biggest challenge to have this model support on vLLM is the new kind of architecture. So unlike other open source, popular open source models out there today, which leverage the language model decoder only, self-attention only language model as is, they actually added additional cross-attention layers, meaning at the inference time, you are not just like concatenating your multimodal embeddings with your text embeddings and feed that to the language model. You're actually doing cross-attention between the two embeddings. This means a bit more complicated inference pipeline pattern, and it adds additional cache management that I have to deal with on vLLM, because right now, the cache management is only on the self-attention block. And also, one more thing to call out here is that these layers are big. So for the full 5B version, they are adding additional 120 billion parameters to this model. And I'm not sure how many of you have tried deploying full 5B with vLLM. Today, the biggest reason why the FPA checkpoint is popular is because you can host that model within one A180 gig box or H100 box. But with additional parameters added to the model, the FPA version of it might not be enough. And so pipeline parallelism will be a bigger kind of factor here to have this model supported. So this is something we're also working on with other committers in vLLM to make sure the two workstream won't have any conflict with each other to eventually support a multimodal version of Llama 3.1. And that's everything I want to talk about today. Thank you for your attention and coming here to listen to my talk. And if you are interested in contributing to multimodal workstream, please feel free to let me know, and or you can just go to that issue I linked and leave a message there. I'll for sure reply to you if you have any questions or interest in contributing to this workstream.
Thanks a lot, Roger. I think that was really informative. I actually had one question just off the top towards support of not just text output for say the, Multimodal Llama 3.1 or even like Chameleon. Obviously, I know we don't want to support vLLM generally doesn't want to aim for like diffusion model support, but maybe for these token-based methods, is that on your roadmap for the long term?
I think for now it is not, because if your generation for the your multimodal generation is based on token based, then you can leverage, you can still get, we will still output the token IDs, right? So you can still leverage those token IDs to have your additional component to generate your multimodal from the token IDs. But for now, I don't think that's on the roadmap, because that will change the interface a lot. It's more like the change we need to do is more like something that adds on top of a vLLM, rather than having it be part of a vLLM. That's the logic why we're not adding that support for now.
Okay, yeah. So can you build that with the Chameleon support now, or is there still some like work there to get not just text tokens out necessarily?
I think there are well, two parts here. First part is when Meta released Chameleon. For those of you who are not familiar with Chameleon, it's a model coming from Meta. Basically, what it did is that they tokenized not only text but also images. That means you can feed your image and text as token IDs into the model, but also generate image or text from token IDs as an output of the model. Today, we do support outputting token IDs as output. So the user can take the token IDs and put that as the input of their additional component to generate the images. But that means like they have to be, or they will be like separate modules in the code versus like one module. Yeah.
Yeah, so just using the raw token IDs in the
Yeah.
output. Okay, that makes sense.
Yeah.
Thank you.
Should I go into this session?
Yeah, if you want to switch over, I can take over.
I guess like before we switch over, is there any question from the chat regarding I'll stop share here, regarding multimodal that can answer real quick? Would prompt adapters, which I think embedding the same way, conflict with multimodal embeddings? I don't really quite get in a similar way.
Yeah, so I think prompt adapters are sort of, they're like right, like kind of like fixed offsets you add to the intermediate embeddings within the model to like guide the model.
Yeah, I think so there are some work around supporting embeddings as input in general. So for now, the thing I was talking about is, you still have your prompt. Your prompt is a string of word. What is in this image? For now, the thing I was talking about is you can feed the API or feed the engine with your prompt, but also feed your image payload as embeddings. And on the fly, you don't need to have that run through the vision encoder anymore. All you need to do is concatenate or like merge with your logic how the vision embedding should be merged with your prompt embeddings. And the final embeddings get feed to the language model. There is a PR in the vLLM repository right now to support embeddings as input in general. That means you can even leave this pre-processed part outside of vLLM and have your final embeddings to be the input of the language model. I think I'm not sure if we want to support that, because that will make the profiling a bit more complicated, because now initially you have a prompt, now you have your final embeddings that are a lot bigger for profiling. Actually, they might leave more space in the engine, because we don't have to process them. But I think it's on the side of like how we make sure the profiling stage can work properly with the embedding as input. So to your question, I don't think there will be any conflict. At the end,
Just to clarify, so I think when prompt adapters create their embeddings, it's the same idea that it concatenates it to the the prompt embedding.
Yeah.
So I just want to, I could envision a situation where if multimodal and prompt adapters are enabled, they like override each other if we're not in sync.
I see. I see. I would imagine that as a kind of API change. I guess you just need to make sure that when we design an API, we make sure that these are, you have your prompt adapter embedding, you also have your multimodal embeddings, and in the end, these embeddings should not like override on each other.
Mm-hmm.
Yeah.
Okay. Thank you.
Does multimodality model implementation support? Actually, maybe we should just go for it, and I'll answer all the questions after during the Q&A session.
Okay, sure. Yeah, we're almost at the question section. So yeah, I'll just go over quickly what's new in the latest release of vLLM that went out, I think on Monday or over the weekend.
Yep.
But basically, as we mentioned before, there was a lot of new model support, and particularly a large expansion for pipeline parallelism, as we're building that PR out, building support for that out. It needs to be manually added to each model. There's also on sort of my personal side, we added support for Nemotron models, the sort of like they're very permissively licensed NVIDIA models. And I also worked with some Twitter users on exporting the Nemotron 4 model from the proprietary NVIDIA format to a Hugging Face compatible format. So we have these 340B parameter models that are going to be used for synthetic data generation and hopefully make some new, really permissible synthetic data sets. So excited about hopefully getting some better data there in the open source. On hardware support, definitely a lot of work on TPU enhancements. Woosuk has been really focused on this. And yeah, I'm pretty excited to see how vLLM evolves in terms of TPU support. Also a good expansion on Intel CPU support and supporting some of the newer features like tensor parallelism for multi-socket inference. And then there's been a lot of work on speculative decoding, as always, good progress here. And particularly, we've hit some sort of major milestones in reaching, I think, Nick from IBM's like sort of goal of getting a 50% speed up in latency for Llama 270B with a model of a certain size. Finally got reached. So we're hitting milestones there, feel really good about it. Another really big thing is we removed the Punica kernels for multi-LoRa inference and replaced them with Triton. This was a large effort from community member. So we're really happy to land that. That means now you can run multi-LoRa on older than Ampere devices. So on V100s and T4s, you can run these now. And also you get better throughput performance for multi-LoRa. Definitely a big community ask. And yeah, we're sort of bringing a lot of the features that we first added to maybe the OpenAI server to offline LLM, like guided decoding, and we're also going to be adding like chat templating and making that more of a first-class citizen. On performance has obviously been sort of priority number 0. After some benchmarks in the community sort of went out comparing against other inference engines. We had a sort of like a lot of known issues here in terms of the overhead with the Python scheduler and yeah, processing inputs and processing outputs. And really this, we've just increased our focus on it. And so a lot of, the contributors in the community has hopped in to identify issues. And yeah, within just 2 weeks, we like essentially increased throughput by like 40% and like really heavy throughput cases. And that, we might get like another 40% in 2 weeks, who knows? There were definitely some big overheads. So really what this, we found this really exciting, strictly because, it shows that a Python-based framework can get to the level of performance of TensorRT LLM, which has always sort of been a concern in terms of like, peak NVIDIA GPU performance. Obviously, vLLM is working on more than NVIDIA GPUs. But yeah, just the fact that, okay, you don't need to write like custom C++ submitted code in TensorRT LLM, kind of closed source / kind of open source, vendor code, you can get to that level of performance with just a Python-based API. So we're really excited and confident that we can increase vLLM's performance a lot for everybody and still maintain the ease of use that it currently has. And then on quantization, actually another really big community PR that's been in review for a few months has been W4A8 quantization. So actually, getting to lower levels of weight precision and memory compression while still getting that int8 tensor core throughput is a really good first result. And Neural Magic especially will be working on more alternatives and hopefully higher accuracy methods for W4A8. And then we've also been expanding support and performance for the FP8 and int8 kernels, the Cutlass kernels that Tyler will talk about in a few weeks, for Ada Lovelace and older GPUs, particularly like T4s, as we first started with sort of Hopper support. And then also now you can run bits and bytes models out of the box in vLLM, specifically just the NF4 formats. But definitely give this a try if you're interested in just running those models out of the box after you've run, say, QLoRa on them and want to have the memory savings. Obviously, if you're interested more in performance, we recommend using GPTQ or AWQ to take advantage of our much more performant Marlin kernels. But bits and bytes should get you pretty far for batch size 1. Okay, let's get to your questions. There are some questions in the chat, but I'll first go through these pre-asked questions that were submitted on the online form. So first, is there a project you would, and if any of these questions are from you folks, please jump up and ask them face-to-face if you want. Is there a project you would recommend to someone that's new to the field of AI machine learning to help showcase the skills you will discuss? Yeah, I mean, I think a lot of this stuff, well, particularly what I focus on is more like performance and quantization and compression. These are only really useful when you're actually doing something important with LLMs. So I think definitely the most important thing to get started is just to use LLMs as a tool and not really worry about specializing or fine-tuning or really getting into some of the more maybe research questions and on like how to get good data or things like this. Really try to, experiment with, prompting LLMs, building pipelines with LLMs, with, retrieval of documents with like RAG, or say agents and stacking LLMs together and having them ask each other questions. I think really that's a really ripe space right now, that there's a lot of low-hanging fruit and a lot of excitement in the community in terms of what can you do with all these great new LLMs that are coming out, both in closed source and open source. And getting more of these like advanced usages and pipelines of stacking LLMs or having multiple passes possibly will make you more aware of the bottlenecks that you get when you're trying to, process like 500 requests in a row, or you need, let's say, like 10 turns of conversations between LLMs, talking to each other. That's when you really start to understand the latency, how many tokens do I need in to process? How many tokens out do I need to process? And what do you really need to optimize? Or, do you need to optimize your sort of output token throughput, or do you need to, so maybe you're more like sort of memory bound at a batch size 1 scenario, or are you, needing to process, say, like really large context lengths, like say like 100K tokens in, you want to like process a whole book or PDF or something. Then you really need to go for sort of throughput and process as many input tokens as possible. This is going to lead to different optimizations and different features you want to enable in vLLM. So really kind of just building things with LLMs as a user of them, and then you understand, what are the things you need to look at in order to serve them efficiently. Okay. Another sort of big question. I'm looking to make deployments of multiple copies of vLLM to deploy multiple models. Here, I think there's sort of a lot of questions of like, can I have multiple instances of vLLM on a single GPU how should I think about the GPU memory utilization parameter? You know, all sorts of these questions. So generally on how vLLM thinks about memory usage of the hardware that it has available is it's going to use all the hardware that you tell it has, right? If you say you're running a model with TP2, tensor parallelism 2, which means it's going to take like the first 2 GPUs it has available, it's going to assume it has all the memory and all the flops, you know, all the compute from those GPUs, and it's going to allocate it. So if you want to run vLLM on a GPU and share it with another instance of vLLM or another instance of another process, then you need to start specifying these things manually, like GPU memory utilization parameter, so that, you know, set that to maybe like 40%. So this one process takes 40%, and you start another process, have it use the other 40%. But, you know, it generally sort of, in the interest of performance, it's going to use all that you give it. So there you really need to sort of learn, or sort of take that assumption, and from there sort of figure out, okay, how do I get vLLM to back off and not take everything that it's given? Because, you know, by default, we want to make sure that whatever hardware you're giving vLLM, it's getting you your values worth out of it. Otherwise, you know, people aren't really happy with vLLM. So yeah, definitely on hosting multiple models on a single GPU, just really tune down the GPU memory utilization parameter as small as you can that it works, and see how many models you can fit on there. So yeah, another question, this comes up a lot, how to free up memory from an earlier instance of LLM. This is a bit complicated because, you know, vLLM allocates a lot of memory, PyTorch allocates a lot of memory. You kind of need to be explicit when you're freeing up this memory. Generally, you know, the safest thing to do is to, you know, delete the LLM object directly and then do the, you know, PyTorch cache flushing or sort of garbage collection functions to try and clean up all the objects. We have some utilities for this, definitely in testing. So we do this all the time during testing, that we can point to. But yeah, definitely reach out reach out to me or open an issue on the project if you want direct pointers there. And then these last 2 questions, I think, are good candidates for Roger.
Yeah. So the first one, do we have specific use case for PDF documents? I think it will be not straightforward to just like filling in the PDF like files directly. You'd have to utilize some kind of chunking strategy to first parse from your PDF documents and chunk them into chunks of text or text with images, and depending on those, you pass them to the model to the inference server. And I think Llama Index or other kind of a chunking indexing library there has already a pretty good integration with PDF as inputs. So I encourage you to check out some examples there. I personally haven't really like heard of or like encountered any user asking about like running PDF as input for as input of multimodal models. But I would imagine that could be a very common case if people knows how to chunk their like pre-process their inputs into text or text plus images to feed to the inference server. The other question is multimodal plan and production popularity. Please plus split to microservices. So for the multimodal plan, I already have my Q3 roadmap in the issue. So feel free to go out and check all the items we have here. We put a lot of effort into like, you know, putting them into different priorities. We have P0, P1, P2, and for each kind of item, we have their corresponding PR linked to the same roadmap. So feel free to check it out. Regarding split into microservices, I assume if the person is not here in the Zoom, I assume like your question is about if we can split you know, encoders. Oh, I think
Yes,
that.
it was me. Maybe I can comment. Maybe I can
Okay.
clarify. Yes,
Sure.
I think you briefly addressed it in your talk of, for example, accepting embeddings from the encoder as input. So basically you addressed it, and I understand that this is the way to robustly support multimodal.
Yeah, so initially, actually, at the very first of the multimodal support, let me actually just go back. Oh, actually, no, I'll just talk about it. So, if you recall the Llama architecture, you have an encoder, you have a multimodal projector, and you have your language model. So at the very first of the PR, I guess the first PR. So yeah, here. So on the left here. At the very first PR for supporting Lava, Xiaowei actually made a change where you can accept the outputs from your vision encoder as an input for the overall language model. But that still means you have to run that feature through the multimodal projector to get the final embeddings. And that's kind of it's a bit interesting because you are kind of separating the image or like the vision path into two parts. You're hosting one part separately, but you still have the multimodal projector in your language model backbone, which doesn't really make sense to me, to be fair. That's why we decided to deprecate that feature, but instead support embeddings as, I guess, multimodal embedding as input, meaning you will be hosting your vision encoder and projector together somewhere else. But on vLLM, you can choose to optionally initialize these two components. I would assume you will not because you already have there somewhere else. And you can feed the embedding as input, I guess vision embedding as input for the language model, the trade-off here is that, before you have these components taking GPU memory in your host, they will be only run once at prefill time. So the compute is actually not that much, but they will be taking GPU space. If you decide to split them out, then the cost you're paying here is network, right? Because these embeddings they are not trivial, especially in the future. If we support videos or multi-image, then the data transfer between the two hosts is not a trivial, I guess, like traffic. So that's a sort of trade-off here, and also latency for sending this data over to the language model inference server. So there's something to think about, but at least we do want to enable that kind of a feature for the people to use them. Yeah.
Thank you.
Yeah.
Okay. Yeah, Devin, you have your hand up if you want to.
Yeah, thank you guys so much for hosting this office hours. I really appreciate it. I have a quick question about deploying with vLLM. My company is using Ray to deploy all of our models. And I see not too long ago, Ray actually came out with an official solution for using vLLM with Ray. I was wondering if you guys are aware of Ray and making, if there's any committers that you guys know of that are making Ray more or vLLM more compatible with hosting on Ray.
Yeah, definitely. Anyscale is another big contributor to vLLM, and they obviously make Ray. So yeah, I mean, I think definitely if there's any issues with Ray specifically, put them obviously on the Ray GitHub. But if there's issues you're having with deploying vLLM and using Ray, especially for like pipeline parallel or for deployment management, yeah, make those issues on vLLM, and the Anyscale folks will see them for sure. And we can point them there more specifically. I mean, yeah, I'll say like there's definitely, when there's any issues with respect to Ray and vLLM, those usually get patched up pretty quick. We do want to support that, yeah, we want that integration to be really good.
Are you aware of any additional resources that people developing vLLM hosted models on Ray can go to, aside from literally the only one page on the Ray documentation where I can find anything about it. Because it seems like a pretty rare use case for a lot of people, which is kind of surprising. The amount of issues created or conversations online around Ray and vLLM integration seem to be pretty scarce. So I was wondering if maybe there's somewhere else that I should be looking to get resources for this.
Yeah. I think in general, it's like maybe some of the things you get into once you start managing deployment with something like Ray, or say like Kubernetes setup, or with like K-server things. Like we use K-server a lot at Neural Magic and have been sort of building reference architectures like using that. It just gets really complicated and really specific to what you're looking for and what works for your deployment style and management of your company. So that's where I think, yeah, a lot of companies just aren't talking openly about how they've developed their specific sort of deployment schemes. So yeah, I think I'm not surprised that there's a lot not really out there in the community on it. We definitely had a lot of we've had asks before on sort of improving quality of docs there and like best practices for like setting up multi-node and sort of auto-scaling deployments. And yeah, we're working on it. We've been putting a lot of work on sort of the Prometheus metrics and building those out to give better handles for people to build like auto-scaling services and things. But yeah, I think it is a bit immature there right now, and it's just a bit hard to write general documentation on that. So I think definitely, asking about it, as specific as you can, ask about help on that. We'll make it easy for people to write, docs to specifically, yeah, document how to deal with that. But yeah, it's a bit of a general problem at the moment.
Sure. Thanks, man. I appreciate it. And this is my first office hour, so in future ones, I will come with more specificity overall.
For sure. Appreciate it. We are getting over time. I'm gonna run to the end of the docs or the end of the slides so that we can call it done. But I will stay on afterwards, and anyone else is welcome to go through the rest of the questions. I want to make sure we get through the questions that have built up on the in the Slack or chat. So in terms of getting involved with the community, there's already some questions in here on how to contribute to vLLM. We have the good first issue tag. There's a lot of issues and a lot of PRs on vLLM. We do our best to prune through it, but it obviously builds up. So, asking things in the issues or on the Discord channel or the Discord, server are good ways to get started. But really kind of just like searching for a topic like LoRa or like multimodal or something in vLLM and looking at the issues and PRs will hopefully get you up to speed and get you a PR, an issue that's related to what you're interested in, and usually just comment on it. And usually the person who worked on that or is interested will get a notification and get back to you. That's how these, open source communities work best. Also, like I said, building tools and deployments with vLLM will get you understanding what features you actually care about or want to see better development on. So that'll make you a better user and contributor over time. Obviously, please give us feedback on the office hours we did today and previously. We will share the recording on YouTube afterwards. And obviously the slides are here, shared in the chat a few times. And just let us know how we can better serve the community here. We have a lot of office hours lined up. Please sign up for future ones. And also let us know if you want to present at one of them. We're definitely open to hosting special interest from the community and not just from vLLM committers. And yeah, Neural Magic is hiring. Also, Roblox is hiring. But yeah, we work a lot on vLLM. We're hiring engineers to work on the very performance HPC aspects of vLLM and on the machine learning and MLOps side of vLLM. So if you're interested in working in open source and getting more enterprises to use vLLM, come talk to us. And that's all. Thank you very much. Sorry for going over time. And that's all we have scheduled for today. And now we'll go back over the questions and for anyone who still has pending questions.